Welcome to this video on the types of machine learning. We will be exploring the core concepts of supervised and unsupervised learning paradigms. What is supervised learning? Think of it as learning with a teacher. The model is trained on a dataset where the answers or labels are already provided. The goal is to learn a mapping from inputs to outputs. This is the most common form of machine learning used in industry today. Supervised learning relies on labeled data. Each instance has input features, denoted as X, and a corresponding target label, denoted as Y. The algorithm adjusts its parameters to minimize the difference between its prediction and the true label. A classic example of classification in action is an email spam classifier. The model is trained on emails labeled as spam or ham. It uses features like word frequency to assign a probability of a new email being spam. Regression is another key supervised task, often used in house price prediction. Here, the model predicts a continuous numerical value, such as a specific dollar amount, based on inputs like square footage and location. The common supervised tasks are classification, which assigns data to predefined categories like fraud detection, and regression, which predicts a continuous numerical range useful for weather forecasting. Now, let's look at unsupervised learning. This is about finding hidden patterns in unlabeled raw data. The model explores the data independently to find underlying structures or clusters, identifying similarities and differences on its own. In unsupervised learning, there are no target labels. The system deduces patterns like the natural grouping of similar items through clustering, or simplifying complex data using dimensionality reduction and finding association rules. Customer segmentation is a practical application of clustering. Customers are grouped based on their behavior or demographics without manual tags, allowing businesses to tailor their marketing strategies effectively. Anomaly detection is another use case for unsupervised learning, focusing on finding the needle. The model learns what normal data looks like and flags everything else as suspicious, which is vital for detecting cyber intrusions. At a glance, the key difference is the input data. Supervised uses labeled data XY, while unsupervised uses unlabeled data X only. Their goals are predictive modeling versus pattern discovery, respectively. You should use supervised learning when you have labels available and a specific target in mind, such as predicting whether a user will churn or determining demand. Conversely, unsupervised learning is ideal during the exploratory phase, when you have new data and want to understand its structure. It is also used to discover latent structures or simplify high-dimensional data. Thank you for your attention. In our next session, we will explore how we measure ML performance, focusing on metrics, overfitting, and cross-validation.